So let's look at what that looks like. So if you have your, get my pen back up here, you have your big R, big Y, little y, okay? You want to see what the different combinations of gametes this is going to make when you produce your 4 different gametes. And the way to do this when you've got 2 of them is just like this. It's kind of like the FOIL method in algebra, if you've looked at that. You just, whoops, you just cross this and this, and that, okay? And then you take your second letter here from the first side, stop that, and this and this and this and that. So what you end up with is, to use a different color, you end up with big R, big Y, right? That's the first one. The second one here is big R, little y. Then going to this little r, whoops, let's see, big R, I'm sorry, little r, big Y, and then little r, little y. Okay? So those are the different gametes that you're going to get. So when you set up your cross, you're going to do it just like that. We're gonna put those on the top row here. Okay? And let's make another row here. And again, the cross of, we're crossing 2 of the same thing. So we're crossing this with another double heterozygous for whatever both these traits are. I don't know. This could be tail length and ear size. I don't know what it is. But anyway, we're going to get the same exact gametes on the left side, same exact daughter cell combinations when these go through meiosis. So we're going to write that here. Big R, big Y, big R, little y. That's a really little y. Let's make it a little bigger. Little r, big Y, little r, little y. All right? So there's all of our gamete possibilities. And let's make our lines cross here and our lines down. And we'll see what all the different combinations are. This is where it gets a little hairy. Okay, let's do our combinations in a different color. Let's go with green. Okay, so this one. These are going to come back together again to make diploid cells. Right now, these are haploid. They have half the chromosomes, one of each, right? They've got the big R from either mom or dad. They've got the big Y from either mom or dad. This one does, and so on and so forth. These are all the 4 different daughter cells that are produced from these. So here you would have big R, right? Those 2, and then big Y, big Y. This is going to be double dominant for both traits. This next one, we got 2 big R's and a big Y and a little y. And you got to be careful when you're doing your letters here. If you can do your letters that look different, your upper and lowercase, that makes it easier instead of just a smaller version of your uppercase. This next one's going to be big R, big Y again. And this next one is going to be big R, big Y, little y. All right, next row down, we got 2 big R's and a big Y, little y. I'll just do my big one first. Even though this one, I'm starting with this one on the left and mixing it with the right, I still do my largest allele first for each trait. Next one is big R, little y. Next one would be big R, big Y, little y. And you can do this ahead of me if you want to. You can do this on your own paper and see if you get the same thing. Next is going to be big R, and then 2 little y's, right? Those are both small y's. Next one, big R, 2 big Y's. Next one is big R, big Y, little y. Next one is 2 little r's and 2 big Y's. Next one is little r, big Y, little y. And last but not least, I know this is a long one, big R, big Y, little y, big R, big Y, little y again. No, wait, I'm sorry. That's actually 2 little y's, right? Yep, little y and little y. Next one is little r, big Y, little y. Next one is little r, little y, little y. And there you have it. Okay. So, again, this is where it's important between genotype and phenotype. So let's count. I'm going to look at these and count out what we have dominant and recessive wise here. So this first one, there's only one, and now there's 4 by 4. So there's 16 different outcomes here, 16 different possible outcomes. So this first one is homozygous for everything. It's got big R and big Y's all the way across. So we've got one that is big R, big R, big Y, big Y. We've got one that is, let's see, how many double big R's do we have? We have 1, 2, 3. And of those, there's only these two that are, here, let's do this. Instead of counting them, let's just circle them in different colors. I like that better. So let's say, let's use orange for this one. So this one is our double dominant. We've got, we'll use blue for dominant for R, double dominant, and one heterozygous for Y. We've got, and you'll see a pattern here. Now this one here, we've got 2 big Y's. What other 2 big Y's do we have? This one. Oops, didn't mean to do that. Let's pick a different color here. Let's do green. So let's go with this one. Let's go big R's and little Y's. How many of these do we have? We've got one here. Big R's, little Y's. That's it. All right? Okay, so there's only one of those. So it's an interesting combination here. Let's do red for this next one. So we got heterozygous for R and homozygous dominant for Y. We've got that one and we've got that one. And that is it. All right, I'm running out of colors here, guys. Let's do purple. Heterozygous for both. This one, double heterozygous, double heterozygous, double heterozygous, double heterozygous. Now see, all those were right across the diagonal there. Now, let's see here. We've got, I haven't used yellow yet. Little r, big Y's. There's only one of those. And I'm definitely running out of colors. Okay, we'll use lines and we'll do zigzags for the rest of these. Sorry, guys. All right, orange. Heterozygous for R. And double recessive for Y. That's that one. We've got, I'll use yellow. Double for R, double recessive, and heterozygous for Y. And then our one lone one here of all, I'm going to circle that one. Ooh, I went double size. This one right here is all, let me circle him, all recessive. Okay, so you see, we've got, for genotypes, there's 2, I'm looking at the blue ones here. There's 2 out of 16 that are blue, right? So 2 out of 16, so that would be 1 out of 8. So you've got a 1 out of 8 chance of having a double dominant for R and a heterozygous for Y. However, for these purple ones here, you've got, for purple, you've got, that's heterozygous for both. You've got 4 out of 16, right? So it's 4 out of 16 for R, big R, little r, and big Y, little y. So that would be 1 out of 4. So you have a 25% chance of having a heterozygous for both traits offspring, which would make sense since both parents were both heterozygous. So that's your biggest likelihood. So just kind of interesting. So it's kind of cool when you put all these together, but it does get a little hairy. So just be aware. Now, let's think about genotype. I'm sorry, let's think about phenotype. I'm going to erase this other side here. So we just looked at genotype. Let's look at phenotype now. And I'm sorry, this is a long video. Bear with me. I just want to show this to you really quick because it's important. All right, so phenotype. What are we going to see? How many of these individuals are going to have dominant traits for R and dominant traits for Y? Well, this one, and I'm looking for alleles that are just one dominant for each letter. This one, this one, this one, not that one, this one, this one, this one, and this one. So there's those. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So 9 out of 16 are going to have dominant for both. Dominant for both. So whatever that trait is, we're going to see the dominant trait for both of those for 9 out of 16 individuals. Now, what about, there's only going to be one individual, this one down here, that's got, I'll use red, this guy here that we did in orange, or we circled, he's our only double recessive. So there's only a 1 out of 16 chance of having recessive for both traits. Recessive for both traits. Okay? I can't write. So you can see now where this probability really comes into play. So if these are two different individuals that you're crossing and I don't care what the traits are, you're only going to see 9 out of 16, or more than half of them are going to have dominant traits for both, or dominant alleles for both of the traits. And only one of them is going to be recessive. So pretty interesting. That was a lot. Sorry this is so long, but again, go ahead and leave any questions in the comment section, or you can also email me directly and ask. And good luck with the rest.